Imagine standing on the southern coast of Spain and seeing an entirely different continent with your own eyes. Just across a narrow strip of water lies Africa. At its closest point, Europe and Africa are separated by only about 13 kilometers. So here's the obvious question. If humanity has built bridges stretching over 50 kilometers, tunneled beneath oceans, and even constructed artificial islands, why hasn't anyone connected these two continents? The answer is far more complicated than distance. The Strait of Gibraltar isn't just another body of water. It's one of the busiest and most important maritime passages on Earth. Every year, more than 100,000 ships travel through this narrow gateway, carrying everything from food and electronics to millions of barrels of oil. Blocking or slowing this traffic would disrupt global trade, making any bridge an enormous economic challenge before construction even begins. But money isn't the only obstacle. Modern ferries already carry millions of passengers between Spain and Morocco every year, completing the journey in less than an hour. Cargo ships already move goods efficiently across the strait, meaning a bridge wouldn't create enough new traffic to justify a project costing tens of billions of dollars. Even if funding weren't a problem, engineers face something far more dangerous beneath the surface. The Strait of Gibraltar sits directly where the African and Eurasian tectonic plates meet. These massive sections of Earth's crust constantly push against each other, making the region vulnerable to earthquakes. History proves the danger. The devastating Lisbon earthquake of 1755 generated a powerful tsunami that struck Portugal, Spain, and North Africa, killing tens of thousands of people. Any bridge built here would need to survive powerful seismic activity for generations. And then comes the seabed itself. Unlike many locations where underwater tunnels have been built, much of the strait contains unstable layers of soft clay and deep underwater channels. These sediments shift over time, making it extremely difficult to anchor bridge supports or safely construct long tunnels. In other words, the geology is working against engineers every step of the way. Ironically, this challenging landscape exists because of one of Earth's greatest natural events. Around 5 million years ago, the Mediterranean Sea was nearly dry. Then the Atlantic Ocean burst through the land barrier separating the two bodies of water. The resulting flood, known as the Zanclean Flood, was one of the largest floods in Earth's history, carving the Strait of Gibraltar and rapidly refilling the Mediterranean. Today, that same opening continues to keep the Mediterranean alive. Less salty Atlantic water flows into the sea near the surface, while denser Mediterranean water exits below. Without this constant exchange, the Mediterranean would gradually become far saltier and dramatically different from the sea we know today. Nature has made this narrow passage incredibly valuable. Politics, however, make things even harder. Spain, Morocco, and the United Kingdom all have strategic interests in the region. Gibraltar remains a British overseas territory, while Spain controls two small enclaves on the Moroccan coast. These long-standing territorial disputes make international cooperation far more difficult than drawing a line across the water. Building a multi-billion-dollar project requires decades of trust and coordination, something the region has struggled to achieve. That doesn't mean the dream is dead. Over the years, engineers have proposed record-breaking suspension bridges, floating underwater tunnels, and even futuristic structures combining transportation, renewable energy, and artificial islands. Some ideas sound like science fiction. Others may become reality one day. For now, though, every proposal runs into the same three barriers: economics, geology, and politics. So despite the incredibly short distance between Europe and Africa, this remains one of the few places on Earth where two neighboring continents still rely almost entirely on ships. Sometimes the greatest engineering challenge isn't how far two places are apart. It's everything hidden beneath the water, and everything happening above it.